Can anyone recall what is the second countable space? Hello?
It is a second countable space if it has a countable base.
It is a countable. Space is second countable if it is the space has a countable base. So, for example, so R is the usual topology where tau is the topology, second countable. Okay, and you may see that this collection of all the all open intervals where the endpoints they are rational. Collection forms a base. Countable base for tau. So you have seen that every second countable space is first countable. Converse is not true. Can anyone tell me an example of a space which is first countable but not second countable? So, can you give me space is but it is not a second countable space.
Sir, tree topology in R.
सर वॉइस क्लियर नहीं आ रही है सर.
क्या सभी के साथ ऐसा है?
यस सर, अब अभी सही है. बीच में ब्रेक हो रही थी आपकी, ज्यादा वॉइस ब्रेक हो रही थी.
अभी ठीक है ना?
यस सर.
हाँ अभी तो सही है.
अच्छा, तो आपने क्या एग्जांपल दिया? R with discrete topology. You can give X where X is an uncountable set. Okay, then uncountable set X D where D is the discrete topology on X. Then this space is not set, however, is a first countable. You have also given another result. So the line of R with the lower limit topology, where tau n is the lower limit topology. Okay? The lower topology. So this space is also a first countable, but not a second countable. Not second. Okay? You cannot argue like this. Okay, we argued here that this base. So here we took this base. Base in this base we took all open intervals with the rational endpoints. So we cannot say this here. So this means this space, sorry, this set, this collection where A and B both are rational number is not a base. Not a base for Rn. In fact, there is no countable base for Rn. Okay. So why this is not a base? Because we argue So let's do this. So suppose x be any irrational number, okay? X be any irrational number, and now take an open set U like this. Okay? So then you know by the definition of a base, from the definition of a base, what we have is for each open set, U, and for each x in U, what we have is here exists a member B in the base such that x in B, and it is complete. You cannot find a member from this B for this U and for the point X. Okay, so see here, for each open set U and for each X in U. So in this case, let us take this open set U and let us take the point X in U, okay, the end point, this point. So you cannot find an you cannot find a member from this collection. So see, in this collection, you have the A and B both rational number. Okay, so you cannot find a member such that X in B, it is contained in X comma infinity. If suppose you could find some, you could find a B, so that B would be of this form, A comma B. Okay, suppose there exists some B such that X in this AB and it is contained in X in B. So from here you see this X is rational, it's irrational, okay? Both A and B are rational, and you are saying X belongs to at this this semi-open interval, okay? So this means X must be greater than A, okay? So X must be greater than A. But if A is greater than if A is less than X, then so from here, from these two things, we get this, but this implies A comma B cannot contain the X comma. This is of this form. This is A. Somewhere here is X to infinity, and say this point is A, and say this is B. So you see this interval, that interval by pink color. So this interval is not contained inside the ray X comma infinity, this ray, okay? So this part is inside this. So this means we cannot argue like we argued here. Okay, any doubt? हेलो,
Yes, sir.
किसी को कोई हाँ कोई दिक्कत है?
No, sir.
So yesterday I told you that the second countable spaces, the property of being a second countable space is a topological property. This means second countable spaces are invariant under a homeomorphism. So here is the truth. Here is the result. Result says if f from x to y, x from x to y be a homeomorph, okay, and x be a second countable space. Then y is second countable. So this is same as saying that the second countable space is being second countable space. Second countable space, the topological space. Let us do this. So how will we know this? Very so what we know, x is second countable. This means there are countable base. Okay, and what we have to show, we have to construct or we have to produce a countable base for y, topology in y. Okay, so let's do this. So proof, suppose x tau be so let x tau be taken countable, okay, and y, say u be its homeomorphic image, okay, homeomorphic image. This means f to y homeomorphic. What do you know about homeomorphic? So since f is homeomorphic, this means f is bijective. Okay, f is continuous.
Inverse is
And
also possible.
f inverse is continuous, or sometimes we say f is open. Okay, is this correct? So
Yes.
both are true. So this is what we know about f. Okay. So now it is given that x is second countable. This means there exists a countable base. Suppose p given by this set, this collection is a countable base for tau. Okay. So what we will do, we will show that there exists a countable base for this topology U on Y. Okay. So what would be the so natural candidates for base? Can anyone guess what would be the natural base for Y? तो कौन सा आपको कौन सा कलेक्शन जो लिटरली y का बेस होना चाहिए, कैसे कर सकते हैं आप लोग? आपके पास x गिवन है, आपके पास y गिवन है, आप और आपके पास एक मैपिंग गिवन है
सर y इंटरसेक्शन
एक
bn
कलेक्शन b गिवन है जो ओके लेट्स डू दैट। तो आपकी बात है, देखिए सबसे पहले bn के बारे में हम क्या जानते हैं? bn किसके सबसेट है? bn किसके सबसेट है?
x के
x के। हमको बेस किसके लिए चाहिए? y के
y के
लिए।
लिए
आपने कहा bn इंटरसेक्शन y, सबसे पहली बात तो bn y में होगा नहीं हो, के बीच में एक x सेट ये है, x y सेट ये है, ये x है, ये y है, यहाँ पर मेरा bn है। आपका bn इंटरसेक्शन y से क्या मतलब है? ये तो बहुत ही एब्सर्ड सा हो जाएगा ना। ये तो नेचुरल कैंडिडेट नहीं रहा, क्योंकि Bn को जो भी आप बेस बनाएंगे उसको y का सबसेट होना पड़ेगा। आई बात समझ में?
यस सर।
यस सर।
हाँ,
सर होम्योमॉर्फिक इमेज ऑफ Bn, सर अगर x का एलिमेंट सबसेट है Bn, तो इसका जो इमेज होगा वो y में होगा।
तो वो y का सबसेट होगा Bn। ओके, गुड, बहुत बढ़िया। किया, but we will prove that, so we will prove that okay, so it b sub y, हाँ, और इसका नाम b star है। So this collection is a countable base. So countable तो ये है ही, क्योंकि आप ये देख रहे हैं ये Bn के इमेजेस हैं, तो उसमें ही मेंबर है जिसपे B मेंबर है, तो काउंटेबल तो ये है। So we have to show this is a base, countable base for U. Okay, so let us do this. So base होने के लिए सबसे पहले इनको ओपन होना जरूरी है कि नहीं? आप बेस में सबसे बेस क्या होते हैं? वो तो टोपोलॉजी के मेंबर होते हैं। टोपोलॉजी के मेंबर्स को हम कहते हैं ओपन सेट्स।
सर वॉइस नहीं आ रही है।
हेलो
यस
हेलो,
सर।
आवाज आ रही है नहीं आ रही?
यस सर।
हेलो,
सर बीच में
हाँ,
नहीं आ रही थी।
मैंने बोला कि इस कलेक्शन को बेस होने के लिए जो सबसे पहली चीज चाहिए वो ये जो मेंबर आए हैं एफ ऑफ बीएन्स, इनका टोपोलॉजी में होना बहुत जरूरी है। मींस इनका ओपन होना जरूरी है। करेक्ट और नॉट?
यस सर।
तो पहली बात, ये ओपन क्यों होंगे? तो कैन यू सी दैट these are open? FBN is open in Y for all n. Can you prove this? You know these things. कोई बताएगा? हेलो,
यस सर।
हाँ, कोई आर्ग्यूमेंट है आपके पास कि एफ ऑफ बी एन ओपन होगा वाई में? नहीं आ रहा तो आप बोल सकते हैं हमें नहीं पता चल रहा है।
सर कॉन्टिन्यूअस होगा लेकिन आर्ग्यूमेंट नहीं दे पा रहे हैं।
क्या कह रहे हैं?
सर हम कह रहे हैं कंटिन्यूअस होगा लेकिन आर्ग्यूमेंट मैं नहीं दे पा रहा हूँ।
कंटिन्यूस
क्यों
क्या होगा?
होगा?
मैंने आपको पूछा कि ये कंटिन्यूस क्या होगा कह रहे हो आप? मैं इस सेट के ओपन होने की बात कर रहा हूँ। ये सेट ओपन क्यों होगा?
ये सर ये ओपन होगा y में सर, क्योंकि ये बेस का एलिमेंट है और बेस क्रिएट करते हैं टोपोलॉजीज को, बेस के एलिमेंट्स क्रिएट
नहीं,
करते हैं टोपोलॉजीज को।
आप कौन बोल रही हैं?
सर साक्षी।
साक्षी, हमको ये प्रूव करना है। मैंने लिखा वी विल प्रूव दैट दिस इज द बेस। हमने अभी प्रूव नहीं किया कि ये बेस है।
ओके सर। सर सॉरी, लेकिन ये सबसेट तो है
मैंने
y का।
हाँ y का सबसेट है, बिल्कुल सही बात।
Sir, since the
लेकिन
mapping f is continuous, and we also know that the continuous image of open sets is open. That's why it will be open.
ये कहाँ से आया? कंटिन्यूअस इमेज ऑफ ओपन सेट इज ओपन, फ्रॉम विच प्रॉपर्टी ऑफ एफ इट इज कमिंग? आपने मेरे को दो चीजें बोली, आपने कहा एफ कंटिन्यूअस है, एफ इज कंटिन्यूअस है, फिर आपने बोला इमेज ऑफ ओपन सेट इज ओपन। ऐसा ये तो कंटिन्यूटी से नहीं आता, कंटिन्यूटी कहती है इनवर्स इमेज ऑफ ओपन सेट इज ओपन। यू सी द डिफरेंस? Continuity says the inverse image of open set is open. You said that image of open set is open. Okay? So there is a difference. Inverse image and image, both are different things. Do you see this point?
Yes,
you are
sir.
correct, but from which property did you say that image of open set under F is open? Your statement is correct, but why are you saying this? So which property of F are you using? Huh? So I have written every property of F. So you can see whatever I have written, it is one of them. Okay.
सर ओपन मैप की प्रॉपर्टी यूज करिए।
ओपन मैप का क्या डेफिनेशन होता है? A function f is called an open map if image of every open set is open. Okay. So, or you can say f inverse is continuous. Because f inverse is continuous, inverse image of f inverse, that is image of f. Okay. Inverse image of f inverse means same as saying image of f. Okay. So this is open because f inverse is continuous, or you can say f is open. Okay, you see these, since this B, this collection, this funny B is a base, all B are all BNs are open, and since F is open, image of F, image of Bn under F is open in Y. So number one thing is okay. So second thing, you have to show that any arbitrary open set G in Y, okay? Open set G in Y. So this means G belongs to U. This can be written as a union of these members of B star, okay? Any arbitrary open set can be written as a union of members of B star. Can you see this? Can you prove this part? Let's do this. So suppose G is an arbitrary open set in Y, okay? And you know F is continuous. F is continuous. What can you say about F inverse G? So since Suppose this is there and we have this. This implies F inverse G. What can you say about F inverse G? So by continuity of F, what can you say?
F inverse G belongs to tau.
F inverse G belongs to tau, means F inverse G is open. Okay, it's open in X. Okay, बहुत बढ़िया. Because this F inverse G is open and this B is a base for tau, this means F inverse G can be written as F inverse G can be written as a union of some members of B. Okay, say B level. Okay, is this correct? Where this indexing set is any subset of Z plus. Is this okay? This is from the definition of base. B is a base for tau, and you know any member of tau is a union of members of this funny B. यही तो बेस की डेफिनेशन होती है ना, कोई भी ओपन सेट को आप यूनियन ऑफ मेंबर्स ऑफ बेस के फॉर्म में लिखते हैं. Is this correct?
Yes, sir.
Yes, sir.
Okay, so from here, what can you observe now? So from here, you can observe that G can be written as F of union lambda B lambda. Okay, which is nothing but union of B lambda, where lambda is 0. Okay, this means this G is union of members of B star. Okay, and see this indexing set is a subset of plus. Okay, this implies any open set, any U open set G can be expressed as a union of members of B star, where B star is F of B. Hence, B star is a base. Yeah. Base for U. Okay. And clearly it is countable because it depends only on U. Clearly it is countable. Thus, you have seen that why you have proven that Y is a second countable space. Okay? Any doubt?
No, sir.
Okay. Before going to the next proof or next theorem, I have an announcement for you. So here will be here we talk or a lecture on demand or IEMAMM demand hypothesis on so far it is on Thursday. If there is any delay, then it would be on Friday, Thursday from 12 noon to talk will be given by Care. हाँ okay, so please attend this lecture. It will be think you will find it interesting. Okay, you will so have you ever taken any course in number theory? कोई कोर्स आपने नंबर थ्योरी में किया हुआ है?
No, sir.
कॉम्प्लेक्स एनालिसिस में आप जीटा फंक्शन पढ़ते हैं? जीटा फंक्शन पढ़ा हुआ है? जीटा एस, रीमान जीटा फंक्शन
सर पढ़ाया गया था सर लास्ट
ओके, पर ये कॉम्प्लेक्स एनालिसिस में पढ़ाया गया था ना. सो प्लीज हैव a look at this part. Okay, रीमान जीटा
सर मैं
फंक्शन क्या है?
रिक्वेस्ट टू यू
हाँ बोलिए.
सर अगर ये लेक्चर ऑफलाइन मोड में जब क्लासेस खुल जाएंगी तब होता तो आई थिंक ज्यादा बेनिफिशियल रहता,
ये
क्योंकि
इसी
कुछ ही दिन
मोड
में
पे
खुलने
होगा,
वाली हैं.
मालूम नहीं
अगर
कब
आपने
खुलेगा अभी.
सर से बात नहीं की हो तो फिर हम लोग शिफ्ट कर सकते हैं.
नहीं कर सकते क्योंकि हम डेट फाइनल कर चुके हैं, इधर डेट और टाइम फाइनल कर दिए हैं. तो आप लोग तैयार रहिए. अगर आपको मीन्स इसको अटेंड करना ऐसा नहीं कि आपके लिए कंपलसरी है. आप अगर स्किप करना चाहे आप छोड़ दीजिए. okay?
नहीं सर मैंने ही तो रिक्वेस्ट किया है सर, मैं कैसे स्किप कर सकता हूँ.
हाँ, अभी जो भी हालात हैं उनको देखते हुए ये ऑनलाइन होगा और आप लोग उनसे क्वेश्चन पूछ सकते हैं अगर आपको समझ में नहीं आ रहा है. थोड़ा सा आपके कोर्स से बाहर का है तो समझ में दिक्कत होगी. कुछ अगर आपको दिक्कत होगी तो आप उनसे नहीं घबराइए. और क्योंकि फिर ये
ओके सर.
डिले नहीं कर सकते ज्यादा और अभी सही टाइम है जहाँ पर हो सकता है. और अभी इस वक्त लोग आने में भी दिक्कत है ना. ऑफलाइन मान लो स्टार्ट होता है तो बहुत से लोग नहीं आना चाहते इन पर्सन. लोग आने बेटर है हम ऑनलाइन बात कर सकते हैं. वो ये मीटिंग वेबएक्स में होगा तो आप लोग अपना डाटा थोड़ा सा बचा के रखिए. क्या इंटरनेट डाटा थोड़ा सा रखिए अपने पास बचा के. ओके,
Okay,
दिस वाज द one announcement. So let us move to another. Then so here is a beautiful result. A second countable space. Every collection of non-empty is joint open. countable. Okay, so in a second countable space, every collection of non-empty disjoint open set is countable. So let us prove this. So you can clearly see this in R. Here line it is intuitive to see every so here it is saying non-empty disjoint open set. So non-empty disjoint open sets are unions of open interval in case of the real line. Okay, they are saying so disjoint open interval. So you take disjoint open interval. So these are countable. And to see this is very easy. You see in each intervals, because they are non-empty and disjoint, you will find rational numbers. Okay, and so you will find distinct rational numbers here. And you know every rational, so this set of rational number is countable. Therefore, it is easy to see this theorem in R, or it is very easy to prove this theorem in R that the any collection of non-empty disjoint open sets is countable in the real line. Let us prove this for let us prove this for an arbitrary second countable space. Okay, so the idea is same. Idea is almost same. So what is the idea? Idea is, let us write this. So we have a second countable. Second countable. Yes. Then if it is second countable, this means there is base, countable base. Okay? And this being countable base for tau. Okay. Now you take any collection of non-empty disjoint open sets. So suppose this take this D be a collection of non-empty disjoint open sets. Okay, open sets. Now you see this funny B forms a base. Okay, this means if you take any member from the G, so for G in G, okay, so you are taking G from this funny G. This means this G, capital G, is a non-empty open set. And since this is open set, this can be written as a union of BNs. Okay, this means you will get for Gn there exists some n. Okay, right? There exists some n in Z plus such that Bn contained in G. Okay, this is by the definition of base. This is by the definition of base. Now you see if you have G1 and G2, so if G1 and G2 be two members of G, two distinct members of G. So G1 not equal to G2. Okay, they are distinct members of G. Then this means there exists M and N in Z plus M not equal to N, such that Bm is contained in G1 and Bn is contained in G2. Is this okay? Why they are not equal? Why PM and BN are different? Because G1 intersection G2 is uh, it's empty. Okay, they cannot be, correct or not?
Yes, sir.
So this means, so this is because because members of this funny G are defined. Okay, this means, since the members of this means for different members of G, we get different integers. Different integers. Okay, so you can see that. Okay? This means if we order the collection, G according to the order of the associated integer. So to every member we are associating an integer. Okay, to every member we are associating an integer. Correct? And you know, for two different integers we are getting different integers. Correct? So this means
Yes.
if we order the collection G according to the order of the of the associated integer. Okay? For each member, we obtain means we will obtain a sequence. Okay, so we obtain so possibly finite. Maybe we will get on the finite which contains the problem. Therefore, okay. So, so whatever I have written here, this means I am getting uh, one map from I am getting a one map from that place. Okay, good. I have to. So let me give you another one.
हेलो
हाँ,
सर, आपकी आवाज
किसी
बड़ी
को कोई
स्लो आ
डाउट?
रही है, पता नहीं।
यस
सबके सबके साथ ऐसा हो रहा है। स्लो का मतलब कि मैं बहुत धीरे बोल रहा हूँ क्या?
यस सर।
नहीं सर, ब्रेक हो जा रही है बीच बीच में।
मुझे आइडिया नहीं है।
आपका ये नेट गड़बड़ कर रहा है।
अच्छा, हो सकता है मेरा नेट गड़बड़ कर रहा हो। ओके, मैं फिर भी कोशिश कर रहा हूँ कि हर चीज जो मैं बोल रहा हूँ वो मैं लिखूं। तो आपको लिखा हुआ तो दिखाई दे रहा है ना?
ये सर
सर
आज
लिखा
पता नहीं
हुआ
क्या हो गया,
दिख
रहा है लेकिन वॉइस
ब्लर हो
ब्रेक हो
जाता है
रही
बीच
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 बीच में।
अच्छा, जो लिख रहा हूँ वो मैं वही बोलता हूँ। ओके, तो लेट x tau be second countable space and a be an uncountable of x, right? Then there exists x in A such that every open set containing x contains an uncountable number of points of. So this is so say this in the real line you have r. So instead of x you have r. Okay. So take instead of a take set of all irrational numbers. All irrational number. Okay. So r minus q or q complement r minus q. Okay. So it's saying that if you take x and a, then there must exist a irrational number x such that if you take any open set containing this x, any open set containing this x, this open set will intersect with a with infinite coordinate, so uncountable coordinate. Okay, so say this u intersection a, say this is okay. Let me write this. This is greater than L if naught. Okay. This is greater than L if naught means U intersection A is uncountable, and this is true for each open set containing U. Okay. So let us prove this. So in R, this is in fact true for every x. Okay. So let us prove this for a general second countable space. So it is given that x is second countable. Okay. This means we have a base which is countable. So a countable base for topology tau. Okay. Suppose this is not true. This property, so there, suppose there does not exist any such x. So what is our claim? Our claim is to find a x such that every open set containing x contains uncountable number of points of x. So suppose there does not exist such x. So this means suppose suppose that no such point exists. No such point exists. So this means there exists. Means this means for each x in A, there exists open set G containing x such that A is counted. Okay. Now you see we have this B as a base. B is a base. Okay. And here is this open set G. So this means for since G is a base, there exists some nx in Z plus such that X in B and X, and it is contained in G. Correct? And since G intersection A is countable, implies B and X intersection A is countable. Okay? Now, what you have, you can write A as a union of all A. You can write as a union of singletons. Okay, let me write it like this. All singletons from it. This is clearly subset union of B and A intersection A. For each X. Okay, so here this for each X. So I can write this. This is clearly a subset of. Okay, and you know these are. This is countable set. This is a countable set. Okay. So this means, and so we can write A as like this, as a union of countable sets. Okay, and thus here can be at most countable number of different indices. Since for each A in A, we must get B and A intersection A. We get an A such that B and A intersection A is countable. Okay. And you know, whenever we take two different X, this means this open set is different from this open set Y. Sorry, this singleton X is different from the singleton Y. Okay, and this is same as saying A intersection B and X is not equal to B and Y, and the same as B and X and B and Y, they are not equal. Okay, therefore, what we get, oh, there exists a 1-1 on 2 map, 1-1 correspondence between elements of A and the members of subclass. Okay, and the members of B. So since we are getting a 1-1 on 2 map between A and members of B, and we know B is countable, this means A is countable. A must be countable. But you see here in our hypothesis, A is uncountable set. This means a contradiction. We are getting a contradiction. Okay. Hence, every uncountable subset of a second countable space. So this means this assumption is wrong. This assumption is wrong. This means there exists such points. Okay. This means hence there exists X such that every open set containing, so this X in A, okay, containing X being an uncountable So such a point is called condensation point. Such a point is called condensation. So this means in case of a real line and a set of irrational numbers, every irrational number is a condensation point of irrational. Okay. So I will stop here. So we will meet on Thursday. So on Thursday I will take class at 8 a.m. Okay, I will take class in the morning, then in afternoon we will have that lecture. Okay.
सर इस नेट मॉड क्या कहते हैं इस टाइम पे और 12 o'clock पे सर नेट प्रॉब्लम बहुत करता है, वॉइस प्रॉब्लम होती है।
थोड़ा सा बचा के रखिए उस दिन। आप
Yes,
लोग
sir.
तो वैसे भी अभी नेट का आप ज्यादा तो यूज करते नहीं ना, मीन्स आप
नहीं
तो
सर
मैं
नेट
एक
का
काम
ज्यादा यूज
करूंगा,
नहीं
मॉर्निंग
करता।
की क्लास उस दिन नहीं लेता हूँ। उस दिन वही 12 से 1
जैसे
क्लास
मॉर्निंग की क्लास सस्पेंड कर दीजिए।
हाँ ठीक है, अदरवाइज फिर नेट आपका दिक्कत
सर
करेगा।
थोड़ा सा हम लोग भी
तो
प्रिपरेशन कर लेंगे सर, उस पढ़ लेंगे रिमान हाइपोथेसिस और फिर जीटा फंक्शन के बारे में।
हाँ हाँ हाँ, तो रिमान हाइपोथेसिस तो वो बताएंगे ही आपको। रिमान जीटा तो वो उसके रिमान जीटा फंक्शन के जीरोज को लेके एक कंजेक्चर रिमान ने दिया था, उसी के बारे में है। तो शायद आपको कुछ और भी चीजें देखने को मिलेंगी, शायद मॉड्यूलर फॉर्म्स और भी कुछ चीजें देखने को मिले। तो आप प्लीज अटेंड करिए और सही से सुनिए, और उनको कोई दिक्कत हो आपको तो कुछ आप क्वेश्चन पूछ सकते हैं। क्वेश्चन सभी लोग पूछिए।
ओके सर।
शांत नहीं रहना आप। अगर वो बोले रिस्पॉन्ड करने को तो आप लोग बीच में हाँ या ना ऐसे बोलते रहिए प्लीज, है।
ओके
और आपको कुछ चीज समझ में नहीं आ रही तो बेधड़क आप क्वेश्चन पूछिए। ओके,
थैंक यू।
ड्रॉप योर